Okay, so thank you for joining me on the last session on the Thursday. Thanks for putting off the beer for another 40 minutes. Don't worry, 25 minutes. So we're here today to discuss bringing continual dynamic authorization to common off-the-shelf applications. So the obligatory, who am I? So I'm Paul Heaney, the CTO and co-founder of ProofID. So we're an identity and access management managed service company with offices in Manchester and in Colorado Springs in the US. So over the last many years, we've spent time discussing authentication. We've done a lot of work around sort of federation, bringing a centralized authentication source, strong authentication, FIDO, biometrics, all of that things. And I'm going to make the bold statement that authentication is kind of broadly solved, that we're all doing it. Yes, there's polish we could apply. Yes, there's refinements, but it's broadly solved. But authentication is only the doorway into your application. Once you're into the application, what can you do in there? And that brings on to the topic of authorization. So it's not a new topic, it's been around since computers began back in the day. But we've historically done authorization using sort of static sets of rules, permissions. We assign you a role when you start the organization, and you probably collect those as you go through. And they define once, and we then enforce them every time you log in and try and do something. But they're very sort of rigid, very basic. So what does this bring as a problem? What can we not do? So they're not aware of the context of the request. So where are you coming from? Am I coming from Manchester? Am I coming from Las Vegas? What device am I using? What am I attempting to do? So yes, I might be allowed to make payments in a banking application, but am I allowed to make payments for £1 million or £10? What am I trying to do? What have I also done recently? So I might have, in an online banking case or in a e-commerce place, actually changed my billing address in the last 30 minutes, and I'm now making a big order. That's perhaps suspicious. I'm shipping now to a foreign location. That could be a sign of a takeover. And it's not able to actually take signals from the wider ecosystem. So if there's been sort of lots of new payments set up to a particular new bank account, you might be transferring £2 or £3 or dollars to that account, but if 1 million people set up a new account in the last 2 hours to that, new payment to that account in the last 2 hours, and they start to transfer money, that perhaps isn't right. In the healthcare scenario, well, what about lots of people looking at individuals' medical records? That there was a case in the UK a few years ago where a celebrity was injured and taken to hospital. He received treatment, he recovered. But when they looked at his medical, who'd accessed his medical records afterwards, they'd find there was thousands of people within the hospital, doctors, nurses, etc., who'd been looking at the person's medical records, but only 7 people had actually treated him. So lots of people kind of being nosy and sticking their nose in where it doesn't belong. Also, there's a lot of legislation coming in now that requires dynamic risk-based authorization. So in Europe, we've got PSD2. The NIST standards are starting to refer to risk-based dynamic authorization. And kind of to get buzzwords in here, doesn't support a dynamic authorization model or an identity first, or to really use the buzzwords, zero trust model. So we've got no way to keep looking at every transaction and making a decision on each individual request. So I've kind of talked about a few examples, but sort of the key, or several of the big use cases that we see in banking and finance, especially on the customer side, that you're in your online banking, your mobile banking, and you're operating in there. In healthcare, as I was saying, sort of people accessing medical records, but also when when patients are accessing the medical records, can I access my children's medical records? Where am I coming from? What am I doing with these medical records? One that's perhaps less seen, but causes a lot of frustration to customers is on loyalty schemes, that you've been shopping at your favourite restaurant or with your airline, you've accrued lots of miles or points, and then somebody compromises your account and spends the money and buys lots of meals with your points or uses your air miles. So how do we control that? In the publishing world, so we've done work with a a publishing company in Europe where they provide a lot of scientific journals, and they've got a big challenge with people stealing that content and actually then either reselling it at a cheaper price or actually just putting it on the internet for free. And they've put a lot of effort into creating that content. So we need to look at who's accessing that content and when they're actually using that. So those are kind of 4 cases that we've come across, but there are many, many more. So to bring a dynamic authorization model into your applications, if you've got a custom application, then it's probably easier to make that change because you've got the code. You can get your developers to go into this code and add in dynamic authorization, look at the transactions and make a request. But for off-the-shelf applications that you've gone and spent a lot of money with a vendor for, then this is much more difficult. That you probably can't get the application changed, or if you can, it's going to take a long time to influence the vendor and make them actually add in the functionality. And this is a scenario that we've come across in the banking sector. We've got a customer where they're doing online banking. They've got a banking platform from one of the big vendors, and they needed to comply with sort of PSD2 in Europe and wanted to do risk-based or transactional authorization, and they just couldn't get the vendor to make the changes. So we're going to kind of look at that. So in the typical world of accessing an application, we've got a very simple case. Our user opens up the web browser and opens the off-the-shelf app, types in the URL, and they access the application, and they're good. So how do we bring dynamic authorization into this scenario? So we'll look at that. So the first part, we're going to need to put something in front of our application. So we're going to put a reverse proxy in front of that application. So the user types in the URL, and now that resolves to our reverse proxy. We're now going to add in a policy decision point. So the reverse proxy receives the request, and it goes to the PDP and says, what do I do? So, or in more formal terms, request a decision. So what data goes in that request that the reverse proxy sends to the PDP? So who is the user? Who's the user accessing this resource? So that might be their username, it might be their email address, the location of where they're based, their department, all those usual identity attributes we know about authenticated individuals. The what? So what is the user accessing? So the URL that they're accessing, the method they're using, so the HTTP method, so post, put, get, etc. What the payload is, so if they're making a request to buy some sandwiches online, then what are they requesting? So you've got the how many sandwiches, where they're going to collect it from, etc. So the usual HTTP, HTML form post method. And then we've also got the request header, so the user agent, the cookies, all those headers that go through. And finally, the where, so the context of the request. Where is this request coming from? Their IP address, the location. Maybe, is it a managed device? Maybe there's a session identifier for there. So we've got these 3 items that we're going to send to the PDP to say, I've got this request, what do I do? But that might not be good enough. We might want to actually look for additional information. So we've got to look up additional information from some policy information points. So those will help us continue to make that the decision that we need. So what kind of information points might we consult? So this is certainly not an exhaustive list, but risk systems. So external consortium-based systems, so things like threat metrics, etc., where we can go and say, this is some details we've got of a request. What are you seeing in the wider ecosystem? So have there been a lot of spates of people buying sandwiches on loyalty points in a particular area of New York, say? Look at internal risk systems. So if you're in a bank, you've got other risk-based systems. So where's your credit card been used? What's your credit record? All those sort of things that a bank might have. And they're also kind of user behavioral analytics systems. So is this the normal behaviour for the individual? Do they usually buy a sandwich at 9 p.m. on a Friday? Maybe, maybe not. We could also look at the the customer's transaction history, so their audit. So have they just, as we said earlier, changed their address recently? Do they usually make a payment or buy sandwiches at 9 p.m. on every Friday? If they do, that's probably normal. But if they're starting to deviate from their patterns, then that's perhaps an indicator that, yeah, everything might not be right. And we might also have, depending on the use case, consent stores. So has the user consented to share this piece of data or do this particular operation? We might have relationships of family, so that the children or somebody who you've got a power of attorney with, that yes, I can access this person's medical records because I have a power of attorney over them, or I can access the medical records because this is my child and the child is under 16, say. Obviously that depends on which jurisdiction you're in and what that age is. And kind of a final interesting example we've talked to some customers about is in the automotive space, that the relationship between the person and the vehicle and all the rest of the individuals in that ecosystem. So the dealer for the car, the owner, the mechanic who's working on the car, what can they access about the car? And as vehicles become smarter, then we're going to have more information in that space potentially. So these are some cases. So we've looked up all the information from the request, from the information points. We've got the data from the request, and the PDP can then make a decision of what to do. So do we want to allow the request to continue? So this all looks good. We've got to allow the request to go. We might require the transaction to be authorized. We'll come back to that one in a minute and see that in some more depth. We might want to filter or modify the request, so we might want to actually add additional information to the request or filter things out. We may want to write some audit data. We might want to update some truth data, so if we've allowed the transaction to go through and it's actually been accepted by the back-end system, then yeah, you've got a correct bank account details, so we're going to allow that to go through. We may say, ooh, this doesn't look right, this transaction, we're going to deny it, we're not going to allow it to happen. Or worst case, this is just so badly, such a bad request, we've got to terminate the entire customer session now and maybe lock their account or trigger a call to an agent for an agent to ring the customer and help them. So the PDP is going to return one or more of these decisions, and then that's going to be enforced by our policy enforcement point, which in this example here, in this scenario, is our reverse proxy. So we're going to kind of go through the example here because it's kind of the most interesting, and that's why you're here, is actually how to do transaction authorization. So the PDP is just going to return an obligation to do transaction authorization. So we've got two ways we can do this really. So we're in a web browser already. Depending on the systems that you use, so you've got deployed within your organization, then you might be doing authentication and authorization of the request through a web browser. So in that case, we're going to need to pause the user's request, redirect them off to the authorization service, and then allow them to come back and resume that request. Or if you've got a push-based system, then we can use things like CIBA to do a push notification to the customer's mobile for them to authorize the request. The second is kind of fairly straightforward, lots of existing implementations. We're going to spend our time on the pause and redirect approach here because that's sort of the most interesting and brings some interesting challenges. So first thing the reverse proxy does is it's going to pause the request. So what we need to do is we need to get the information from the transaction, from what we're currently doing, and store that in a way that we can come back and resume that after we've authorized the request. So we're going to store the current request, which is going to be things like the URL, the HTTP method, the body. We're going to store that in a JWE, so we're going to encrypt that so that it can't be tampered with by anybody, and we're going to add that into the state parameter. So we're going to use OpenID Connect as the authentication method. So we've got the state parameter. We're then going to need to be able to pass the details of the thing that we're asking the customer to authorize. So it might be the change of address, the medical update, the banking, the payment request. So we're going to store details of the transaction in a JOT and put that into the OpenID Connect request object. So we've got the details there, so we can resume the request and allow the authorization server to actually show the details to the customer. The final thing we need to do is create a unique transaction ID. So the way we're proposing doing that here is using a scope. So we're using dynamic scope. So we prefixed it TXN auth. It doesn't have to be, it could be anything you want. But the crucial part is we've got a unique transaction ID. To make this unique, we've got to take a hash of, amongst other things, the request URL, the method, the payload, and timestamp data to make that unique. And we're going to use that to create a transaction hash. We then do the standard OAuth OpenID Connect redirect to the authorization server. The authorization server is going to display that transaction detail out of the request object to the customer. Because they're already authenticated, we know who they are. We just need them to enter their password or do their biometric authentication to authorize that particular transaction. So we're going to have the user authorize that, and we then redirect the customer back to the redirect URL, back to the reverse proxy. At this point, we've got the authorization code. We're going to do the usual OpenID Connect dance to get an access token. And at this point, we've got an access token, and we're going to start to look to see, did the customer successfully authenticate and authorize this transaction, or has there been some nefarious actions in place? So what we've got to do is we've got to start to unpause the transaction by reassembling the initial request from the state. So we've got to get out as before, sort of the redirect URI, the payload, the method, etc. We can then take a hash, do the same hashing algorithm over the same data to see what's the transaction ID for this particular request, and then we can look within the returned access token what scopes were actually in here. And if this is a matching request, then the transaction ID we've just generated will also be the same as the transaction ID that's in the scope that's been returned. If those match, brilliant, nothing's happened, nobody's done anything malicious, and we can then allow the request to resume and go through to the back-end application. And we've now been able to bring transactional authorization to off-the-shelf applications. So we've talked about the request. So the blue here is the reverse proxy. So people regularly think of using a PDP to make decisions on the request, but we've also got the reverse proxy sees the response that goes back as well. So we can make a second call to the PDP based on the data that we've got back from the backend application, send that to the policy decision point. We might have different information points we're interested at this point, we might have none. One big use case I've seen for this is the case of updating that truth data. So we've tried to make a transaction. We've seen that on the request that I've just tried to make a payment to Fred Blogs for this account number and this sort code or this account identifier. We've done the usual PDP on the way through. We might have done step-up authentication or transactional authorization for that. Get to the app. That's then actually gone into the banking logic or the logic of the application, and it's done the checks to see, well, is this a valid account number and sort code, etc. As we're getting the response back, then we can take that data and update some truth data if we want. We want to say this request came through initially and it actually succeeded. So we can add a flag to that and say this request came through and it was successful. So that gives us some confidence this user is actually genuine. You can also use this to write audit data out as well if need be. You could also use it if actually there's something dubious coming back on the response. You could use that to deny the request or actually filter data out. So we might say we're going to filter out some fields. If it's an API request, we've got to filter out sort of date of birth perhaps because we don't want that to be returned, or we're going to filter out content on a web page. That's a bit more difficult because you're kind of starting to mess with HTML and restructuring it, and it just becomes fragile but technically possible. So kind of as the takeaways from this, so dynamic authorization is something that's been discussed several times this conference. It's becoming more and more prevalent. We're seeing more legislation, standards requiring it. It also gives a much better customer experience that we're not continually prompting them to authenticate, we're actually doing it on a risk-based decisioning basis. So to be able to bring dynamic auth to existing off-the-shelf applications, then deploy a reverse proxy in front of that, implement a policy decision point alongside that so we can have a centralized decisioning point so the business can potentially go in and change the logic. So we might want to do, we might have a threshold of £50 a day for a step up on payments, but actually we now want to set that to 100, or perhaps we set it down to 20. Using pluggable information points is key here. If we've got these plugged into a central decisioning point, then as the world moves on, as the business's needs move on, then we can actually plug in new information points or remove information points, so we can continually adapt, continually get more accurate information from the customers, make more accurate decisioning requests. And by having those in the centre, we can easily plug those in, and we don't have to change lots of applications. Finally, sort of on this, using open standards like OpenID Connect allows us to easily integrate this, have integrations with any identity provider you want, so it could be Okta, Ping, Shibboleth, etc. And it's well understood and very well sort of tested and known across the industry. So those are kind of my key takeaways about bringing dynamic auth to off-the-shelf apps. So kind of roughly on time. So any questions?
Going back to that one slide that talks about the, going back to that slide with the policy information points that may be consulted, you have, going back into the matrix, you have a bunch of them. Yeah, right there.
Yep.
So what are you thinking? Like, I could see some of these in the blue, like Yuba, right? But when I look on the right, family relationship, vehicle dealer, owner, from a dynamic authorization, I don't see the application for like a workforce user, but do you see dynamic authorization being leveraged in maybe CIM
yes.
type of?
Yeah, definitely. Yeah, those are definitely on the right. Are definitely much more customer-facing SIAM deployments. And yeah, the use case that we've done a deployment on is a SIAM deployment for frontline banking for customer access. So yeah.
I can give you a family use case if you want, where in a bank that a person loaded debit orders onto all of their family accounts. So, you know, basically, and put it under the threshold of the notification for SMS or email, and basically started testing first with their family members to see whether they could, you know, just take a bit of money every month without them noticing. Yeah. Question from my side, what is the reverse proxy that you used, yeah?
So the deployment we've done for the customer was based on ping access, but it could be Nginx or...
Okay. And then I'm assuming from a ping access perspective, you specifically looked for URLs as opposed to evaluating every URL?
So we evaluate most URLs. Yeah, there's a rule to bypass for some applications,
yeah.
But yeah, we're pretty much inspecting every URL, and then in the PDP we've got these are the URLs we care about. If we're not in that list, just return a low.
Okay, cool.
So rather than sort of trying to have sort of lots of configuration to places, just send everything to the PDP and let that make the decision. And we've found it's sort of, there's a little bit of overhead, but it's kind of milliseconds.
Okay, cool. That answers my next question, yeah. And then from an application perspective, so obviously if they upgrade or patch the app and that URL changes or the payload's different, I mean, you're going to have to go and...
You're going to have to go and, yeah.
Do some heavy lifting again.
Yeah, what we found is that for a lot of these off-the-shelf, these typically tend to be older apps that are changing less frequently, and yeah. We did run into a few interesting scenarios where there was one screen this is going back a while actually now, that it was making an international payment that was a lot of data that was in the post payload, and we hit some issues with Internet Explorer and redirects, but that was Internet Explorer. Do we really care?
Thank you.
Okay.
So how much trouble do you have with state resumption on redirect back into the application? It seems like that might be difficult on the off-the-shelf app to be able to resume into a given transaction if they didn't anticipate the need to redirect into an operation.
So we've had no issues in the deployments we've done, but what we've made sure is that the session timeout on the back-end application is higher than the session timeout on the authorization service. So yes, you could have a challenge where if the request comes in, you redirect off the authorization server, it takes the customer 2 hours to authenticate, you come back, then the back-end app has terminated the session. But what the cases we've done have been in banking, so we've done sort of 5-minute timeouts, and we just made sure that the back-end session length is higher than 5 minutes.
Gotcha. And then is there, I guess, follow-up, is there any dream to do a little less redirection or somehow intercept and just have it preserved?
So if you've got a system where you can do a push-based authorization to the customer's mobile phone, then yes, you could just have the screen sitting there with kind of a spinner or sort of please open your mobile phone or the relevant messaging, and then just send a push to the customer, so you don't have to do all that redirecting. So yeah, that is possible.
Thank you.
Sorry, this is a silly question, but what if the employee is in a coffee shop? Do they have to essentially VPN, kind of going back to the pre-Zero Trust days?
They don't need to VPN, no. And I think in the coffee shop case, it's sort of, is it you or is it somebody else using your laptop and you just left it unlocked whilst you've gone to the counter? So in that case, it's going to evaluate the score and say, you're in a coffee shop. Yeah, let's perhaps do a step up or...
Yeah, I guess the question is about the reverse proxy.
No, so the reverse proxy could still be directly on the internet, so it could just be another container in AWS or another server in your data center that's just sitting on the internet. That's the DNS that gets updated to point to your app.example.com now points to the reverse proxy that's on the internet that then proxies into the internal app. So yeah, there's no need for reverse proxy for VPNs.
All right, thank you so much for coming, and thank you, Paul, for a great session, for closing this out on Thursday.
Yep.